Welcome to SPT Online Classes. This is narrated by Paulos Thomas, lecturer in physics. I'm going to explain today the period of functions. So, sometimes you might have a doubt to calculate the period of a particular function. For example, let me write over here a function which is sine omega t. Now, the question is coming, imagine what is the period of such a function sine omega t? We know that the period of function sine omega t is 2 pi by omega. So, if more complex functions are coming, how will you calculate the period? The method is very simple. First, you write 2 pi in the numerator. In the denominator, you write whatever be the term adjacent to t is coming. In this case, it is omega. Okay, suppose the function is cos omega t. Cos omega t. What is the period of cos omega t? The same way I said, 2 pi divided by whatever be the adjacent term of t, you have to write that. Got it? So, period of sine omega t is 2 pi by omega, cos omega t is 2 pi by omega. Now, what about sine to omega t? Let's write sine to omega t. What is the period of it? It is 2 pi by 2 omega. Similarly, cos 2 omega t will be having a period of 2 pi by 2 omega. So, whether it is sine or cos, that doesn't matter. The question is it a sinusoidal function? Then this is the method you have to follow. In case if functions are coming as higher order functions, these are simple order function or linear order function. It's not difficult to solve the period of linear order functions. What about higher order functions like something like sine square omega t? Let's write sine square omega t. What is the period of such a function? Here we need to do something extra. Here you should know the trigonometric identities. So what is the trigonometric identity of sine square omega t? That's what you have to think right now. So the trigonometric identity of sine square omega t is 1 minus cos 2 omega t by 2. 1 minus cos 2 omega t whole divided by 2. So now you can rewrite this function as 1 by 2 minus 1 by 2 cos 2 omega t. Now what is the period of cos 2 omega t? Which we know it is 2 pi by 2 omega. So even though a constant is coming along with that, it's not going to change. I'll explain why it's not going to change, but for the time being understand that a constant along with a sinusoidal function is not going to change its period. Again, even if you add a constant to a sinusoidal function, the overall period is not going to change. The reason is because this constant 1 by 2 is also going to have the same period 2 pi by 2 omega, which I'll show you within few minutes. So what you should understand that any constant along with a sinusoidal function, either by multiplication or by division or addition or subtraction, is not going to change the period of the given function. So we can conclude that the period of sine square omega t is 2 pi by 2 omega or pi by omega. Now, if cos square omega t is coming, how will you write cos square omega t? Once again, you should know the trigonometric identity, which is 1 plus cos 2 omega t. 1 plus cos 2 omega t by 2 is what you should know. So here it will be equal to 1 by 2 plus 1 by 2 cos 2 omega t. As I said before, this is having period 2 pi by 2 omega. So this half also will have the period 2 pi by 2 omega, and together the entire function will be having 2 pi by 2 omega or pi by omega as the final period. Understood? So we studied uh, the periods of sin omega t, cos omega t, sin 2 omega t, cos 2 omega t, sin square omega t, and cos square omega t. Now let me take sin cube omega t. What is the period of such a function? So even and right now I am making it more higher order. So what is the period of such a function? For that you should know the trigonometric identity, which is sin 3 theta. Sin 3 theta is equal to 3 sin theta minus 4 sin cube theta. 3 sin theta minus 4 sin cube theta. And what is sin cube theta from that? Sin cube theta is equal to 3 sin theta minus sin 3 theta divided by 4. And thus you can rewrite the given question sin cube omega t as 3 sin omega t, correct? 3 sin omega t minus sin 3 omega t divided by 4. Let me make a small correction over here. Yes, sin 3 omega t whole divided by 4. Now, as we discussed before, what is the period of 3 by 4 sin omega t? 3 by 4 sin omega t will be having a period 2 pi by omega. Now the remaining term, what is the period of 1 by 4 times sin 3 omega t? 1 by 4 times sin 3 omega t also will be having a period of 2 pi by 3 omega. Thus, the common period of the function sin cube omega t is 2 pi by omega, because 2 pi by omega is there in both 2 pi by omega as well as 2 pi by 3 omega, and this is our common period. So the answer is 2 pi by omega. Similarly, you can do for cos cube omega t. For that, what you only should know is that the trigonometric identity cos 3 theta. What is cos 3 theta? It is 4 cos cube theta minus 3 cos theta. Previously, the trigonometric identity of sin 3 theta we studied as 3 sin theta minus 4 sin cube theta. Here it is 4 cos cube theta minus 3 cos theta, and from which you can calculate cos cube theta. Cos cube theta you can calculate, it will be equal to cos 3 theta, okay, plus 3 cos theta whole divided by 4, and it also will be having a common period of 2 pi by omega once you solve it out. Okay, now imagine a function e raised to minus omega t or log omega t. Okay, two functions are given, e raised to omega t and log omega t. What is the period of these functions? So first of all, we should know that one fundamental thing that a periodic function should have is that it should repeat. And here in this case, e raised to omega t will decrease as t increases. So monotonically, the value of e raised to omega t is going to reduce and it's not going to repeat. Similarly, log omega t. As the value of t increases, log omega t is not going to repeat. That means these two functions are not periodic functions. They are not periodic functions. Since they are not periodic functions, they are not going to have any kind of period. So simple as that, we can study that exponential functions and logarithmic functions are not going to have any period. Did you understand that? Now, imagine a compound function, something like 3 plus sin omega t plus say cos 3 omega t is given. Okay, f of t. Imagine a function is given like that. You might be thinking that this is a mathematics class, but here in this physics we need to calculate period because the applications of these functions are immense, which I am going to say right now after this problem. So here we know that sin omega t is having a period of 2 pi by omega. Cos 3 omega t is having a period of 2 pi by 3 omega, correct? This 3 will be having the common period of these two, which is 2 pi by omega, and you might be still under confusion how these constants are changing periods every time. That's what I'm going to say next. and together, whole together, the period will be 2 pi by omega. Hope you understood how to calculate the period of a sinusoidal function or a non-sinusoidal function. Imagine I'm giving you a function, say let it be 6 plus 4 sine omega t. Now where we are going to apply all this? This is the question. Where is the application going to come? That's exactly what we need to know. Studying simply the period of all these functions, what is the advantage? Where are we going to use this? So simply for studying for entrance purpose, it doesn't make sense. You should know the application. This is the part of oscillations, which we know that it is in NCERT chapter 14 in +1, right? But you should know, even though you are studying these functions and you are calculating the period, where you are going to use it exactly. So let me treat this magnitude 6 from an engineer's point of view as DC. Let me treat this 4 sine omega t as AC. So once you treat like that, then the term 4 immediately becomes the magnitude of AC. Sine omega t is the sinusoidal function of AC. So simply, if someone is telling you to draw the graph of 4 sine omega t, how will you draw? In that case, you will be drawing a y-axis, x-axis, and you will be drawing an alternating current just like that. And you will mark this amplitude as 4. And since it is a sinusoidal function, this is 4 sine omega t. And you will mark over here as time period and here it as voltage. Okay, now what about a DC? If someone is asking you to draw the waveform of DC, how will you draw? So imagine this is the reference, which is time, and over here it is voltage, and you mark this 6 volt like that. Okay, so what happens if you combine a DC source along with an AC source? That's what I'm going to draw here. And that's where we are studying all these things. Okay, simply studying the functions and its period doesn't make sense. Okay, let me combine these two. So what we are going to do now, we are going to combine AC and DC, and we are going to study how does a graph of 6 plus 4 sine omega t looks like. For that, first let me draw the graph and then I will explain how I drew this. So this is 4 and this is our real reference line. Okay, this is our real reference line, which is our time axis, and this part is 6 and this is voltage V. So now I can explain why the 6 is also getting the time period of 4 sine omega t. The reason is because the resultant graph you are going to get is a shifted AC, and the period of this shifted AC is nothing but the same time period of the independent AC wave. Am I correct? So even if you add or subtract DC to that, the time period is not going to change. Got it? So this is going to repeat again. This is going to repeat again, and that's exactly why we didn't change the period of the function. That's exactly why we didn't change the period of 6 into something else. So 4 sine omega t is having a period of 2 pi by omega. So 6 is also sharing the same period 2 pi by omega, and thus the common period is getting for the function, which is 2 pi by omega. That's exactly why it is so. Okay, now if you take another function, say something like this is something interesting, f of t, which is equal to 3 plus 4 sine omega t. 3 plus 4 sine omega t. Imagine if you connect a bulb. Okay, I'm going to connect a bulb along with a source, which is actually the combination of DC and AC. DC and AC. And the DC voltage, let it be 3 volt, and the AC voltage, let it be 4 sine omega t. Can you just predict the brightness of bulb, how it is going to change? So here, if it was like that of the previous case, like 6 volt and 4 sin omega t, then the bulb will glow to its fullest brightness and it will become dimmer and dimmer, but it will not turn off. Why? Because the graph, you can see, it is never going to zero reference line. Understood? Instead, if the DC is changed to 3, now comes the most important part. If it is changed to 3 volt, then how will the graph looks like? So let's draw the graph first, then only you will understand. Okay, so what I'm going to draw is first that 4 sin omega t, it goes like that, 4 sin omega t, but I'm going to draw the real reference line as here. Okay, this is my real reference line, and this voltage, okay, this part is my 3 volt and this part is my 4 volt. This part is my 4 volt, which means there is a small portion below coming under the original reference line. Okay, original reference line, which is our -1. That indicates that the AC voltage wave is actually passing through, a point, 0 reference point over here and over here. It is cutting the 0 reference line. That means the bulb will turn off. Understood? The bulb will turn off in between. So that's how it shifts. So let us check that how it actually works. Then you will get a clear picture. So other than that, hope you understood how to calculate the period, of sinusoidal, non-sinusoidal function, and where exactly we are using the combination of this magnitude cell as well as the sinusoidal function. So you can see all these in the AC, chapter AC. So we connected oscillations with chapter AC. Right now you are going to watch the simulation of these compound functions like sin omega t plus cos omega t, or you can add DC along with AC. That's what you're going to see it right now. In this simulation, you can see an AC source, a DC source, a light bulb. AC source is of 4 volt, which I have connected, which you are not able to see right now, and it is of 50 hertz. DC source is of 6 volt. What you're seeing itself right now is the waveform, which is varying from the maximum voltage, which is 10 voltage, and the minimum voltage, it will be 2. Okay, that we have discussed before. So if you are connecting a 6 plus 4 sin omega t, and this is the concept. If you are connecting a 6 plus 4 sin omega t source, it will be having a DC part which is 6 volt and AC part which will be 4 volt, and the bulb will never turn off. It's becoming dimmer and dimmer, but it's not going to turn off. Now what I'm going to do is that I'm going to change this 6 volt. I'm going to change the 6 volt into 3 volt. So what we can see, let's change into 3 volt. So you can see the shifting of the graph. Now you can see exactly the graph has crossed the 0 reference line and the bulb is turning off. Okay, what is the maximum voltage? Maximum amplitude, you can see clearly it's written over the maximum is 7 volt and minimum is -1 volt. That's what we have discussed before. So the application goes on like that, and here this is the combination of AC and DC. So don't consider it as just to calculate the period of a function, but more than that, there are a lot of information inside it. So always learn whenever you take any topic. You always try to understand the applications of it, and just don't try to learn it by heart, or just don't try to learn it for entrance purpose. Hope you understood. Got it? So that's for the day. Thank you.